Okay, this is Algebra 1, lesson number 19. Today we're going to talk about exponents, powers of negative exponents, and roots, and how to evaluate them. The definition of an exponential notation is going to be when you have x times x, blah, 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 is equal to times x to the nth power. Okay, where these are all called the factors. Right? So we have 2 times 2 times 2. That's the same thing as 2 to the third power. Yes? We call that exponential notation. So we can use 2 as a factor 3 times. Okay? So this is the general form and the formula, the definition of it. Now, we call the letter x represents the base of the expression. The letter n represents the exponent. So x is the base, and n is the exponent. So basically we say this is the base 2 is x, and the exponent is 3 on this example. Okay? We say the value of an exponential expression is called the power of the base. So 2 to the third power, we read this as 2 to the third power. Okay? Or we say that the third power of 2 is 8, right? Because it's 2 times 2 times 2. Or we'll say 2 is raised to the third power. So we also sometimes call this power. There's just different ways of saying them. Okay, so let's do some problems. Let's look at 19b. It's pretty easy. This is a pretty simple one. So if you have 3 to the fourth power, it means 3 times 3 times 3 times 3. Yes? It's just simply 81. 3 to the third power is simply 3 times 3 times 3, or 27. Now let's look at this one. Negative 3 raised to the fourth power. This one, we have to be careful because negative 3 to the fourth means the opposite of negative 3 to the fourth, and it does not mean this. Okay? It means the opposite of 3 raised to the fourth power. So then it's negative. What is 3 to the fourth power? We said it's 81, right? Because it's a positive 3. 3 times 3 times 3 times 3. Then we have to multiply by negative. So this answer is actually negative 81. All right, so let's go a little bit further. So let's look at example 19.2. Let's look at A. All right, so if we have negative 3 squared, this says everything inside here times to the second power. So now we have negative 3 times negative 3, which is going to give me a positive 3. What if I had negative 3 raised to the third power? Well, that simply says negative 3 times negative 3 times negative 3. Because that negative is inside the parentheses, it's also raised to the second power. If it was outside the parentheses, or if it was without the parentheses, then this does not get raised to that power. Okay? So because it is, so now you have 3 negatives multiplied by each other. And we learned earlier that if you have an odd number of negatives multiplied by each other, you're going to get a negative number. So we know the answer to be negative, and 3 times 3 times 3 is 27. Okay, let's look at negative 3 raised to the fourth power. That means negative 3 times negative 3 times negative 3 times negative 3. Right? 4 times. So we've got an even number of negatives, so it's going to be a positive answer. 3 times 3 times 3 times 3 is 81. So your answer is simply 81. Now let's look at this. Well, we have a negative. So we said it's simply the opposite of negative 3 raised to the fourth power. Yes? So simply you have 1, 2, 3, 4, 5 negatives multiplied by each other gives you a negative, and then 3 times 3 times 3 times 3 is 81. So your answer is negative 81. Okay? So now let's look at a problem. Let's look at this one. Negative 2 squared minus 4 times negative 3 cubed minus 2 times negative 2 squared minus 2. Okay, this negative is not inside parentheses, so it means the opposite of 2 squared. So negative with 2 squared is what? 2 times 2 or 4. Minus, here you have 4 times negative 3. It's inside parentheses raised to the third. So here you have negative 3 times negative 3 times negative 3. So you have 4 times a negative 27. Yes? Then you have here a 2. Okay? Negative 2 is inside parentheses squared. It's going to simply be 4 minus 2. So now we just keep going. Minus 2. Negative 4 times a negative 27. That's going to give you a positive 108. Negative 2 times positive 4 is a minus 8. Minus 2. And then you've got here 10. These two equal 100. Minus 4. Oh, sorry, this is 4. I dropped this. 100 minus 6 gives you a positive 94. Okay? Now let's look at, sorry, I didn't mean to erase it so fast. Let's look at roots. If we say 3 times 3 is equal 9, so we say 3 is a factor twice, the result is 9. So thus 3 is the positive square root of 9. So the square root of 9, positive square root of 9 is 3. Just like 3 times 3 times 3 is a cube root of 27. And 3 times 3 times 3 times 3 is a fourth root of 81. And we can also go and do 3 times 3 times 3 times 3 is the fifth root of 243. Okay? So if n is an even number, all right, every positive real number has a positive nth root and a negative nth root. We use the radical sign. This is called the radical sign to designate the positive even root. So for instance, that means square root of 3. If I did negative square root of 9, the answer would be negative 3. If I did the fourth root of 81, it would be just 3. So I have to take 4 out. If I did the fifth root of 243, it would be positive 3. So we call the number inside or under the radical sign the radicand. And the root is this little number here is an index. It tells us what root to take out. If there's not a number there, it's an implied square root, or 2, like this one. But this one you have to take 3 out, this one you have to take 4, and this one you have to take 5. And we say if an n is an odd number, every positive number has, and this is considered n, has exactly one positive nth root and a negative number has exactly one negative nth root. What does that mean? Well, let's look at an example. Clarify this a little bit. If I say this is a cube root of 27, I have to take 3 out, and it's positive, so the cube root is going to be positive 3. And then what if I did this? The cube root of negative 27, right? Because we know we can break this down to negative 3 times negative 3 times negative 3, because negative times negative times negative gives me negative 27. So this one is a negative 3. Okay? And what if I had, and that's all there is. So let's look at example 19.5. 8 says the square root of 64. So the answer is going to be simply 8. This one says the fourth root of 16. Well, I have to factor this down. It becomes 2 times 2 times 2. I have to have 4 to pull out, so my answer is simply 2. And if I do the cube root of negative 27, like I just did, I have to factor that. Negative 3 times negative 3 times negative 3. So I've got 3 of them, so I can take out a negative 3 as my answer. Now let's look at this one. If it's on the outside, it's the opposite. So the square opposite of the square root of 81. Square root of 81, because there's no, the nth is implied 2, is 9. So I have a negative 9 as my answer. Okay? Now how do you evaluate power? So let's look at this one, 19.d. If I have y x squared mq. And I said y is equal to 3, and x is equal to 4, and m is equal to 2. Simplify this expression. Well, y is 3. This all means times. What is x? 4 to the second power. M is 2 to the third power. So 3 times 4 squared is 16, times 2 cubed is 8, and multiply 3 times 16 times 8, and I get 384. Remember, when you have variables next to each other, it means multiplication. It's an implied multiplication. And you simply just put these numbers in, 3 for y, 4 for x, but it's squared, so you have to square the 2. If it was negative, the whole thing, and inside the parentheses would be squared, the whole negative. Okay? Just like if this was a negative 2, this would be a negative 2 cubed, which says negative 2 times negative 2 times negative 2. It's all raised to that power. Then that would become a negative 8, and this would be still positive. Then you would have a negative 384. And that's all you do. Okay, so your homework on this lesson is to do all the practice problems, A through H, bring them to class. And on your homework, lesson 18, I need you to put hello in the top right-hand corner. So just the word hello, okay, in the top right-hand corner of your homework, lesson 18. Okay, that's it.